Okay, we have another video here using the idea of an array and the commutative property, which we talked about in the last video, which tells us we can change the order of a bunch of factors without changing the product. Commutative product rule, we can call it that, or the commutative property it's usually called, which tells me if I take a number, multiply it by another, I can change the order without changing the answer. Right? 2 times 3 is 3 times 2, same thing. And all I did was change the order. That will really help us out with these fractions. In the first case and the second case, we're going to get the same answer. Either way, we're going to get 2/7. And let's just walk through that. The first step in a standard algorithm is to multiply your numerators over your denominators. And then we get 12 out of 42. If we reduce that, if we divide by 6, we get, dividing 12 by 6, we get 2. Dividing 42 by 6, we get 7. So there, we did get 2 over 7, like I said. And now we have the same situation happening. Notice, though, that the order of the numerators has been switched. First we had 2 by 6. Now we have 6 by 2. And nothing else changed. So we talked about in the last video, well, that means that we'll get the same thing, right? And we do. It doesn't matter the order. So we don't look at this to understand what's happening. Well, first of all, when you see the situation where you have a numerator and a denominator that matches, it does make sense to actually switch these two numerators around to read this statement here. And the reason it makes so much sense is because now you have 6 over 6. And that cancels out, because this means what? It means 6 divided by 6, which is just 1. And we don't even need that there, because 1 times 2/7 will ultimately give you 2/7. So you can almost see the answer. And that'll always help you if somehow these numbers match across like that, or if somehow they're factors or multiples of each other. And you can quickly deduce what an answer might be. Like if I give you a nasty question like, oh, what's this? 5 over 6 times 6 over 13. Well, if I switch these two 6's around right here, eventually they would divide and cancel out. So the answer is 5 over 13. And if you want to look at why it's okay to switch around the order that you're multiplying the numerators, you can think about the array. If we had a 6 by 7 rectangle, rough sketch here, right? If I multiply out 2 by 6, maybe we go like this. Oops, sorry about that. 2 by 6. The rectangle looks something like that, have an area of 12. Right, we multiply 2 by 6 to get 12. Well, what if we did 6 by 2? Let's look at that. If instead of 2 by 6, it would go 6 by 2. Now my drawing's terrible. However, you might recognize that what I'm trying to get at is that this rectangle has the same area as our original rectangle. So all we did was change the order or direction of our shape in our array. Either case, this rectangle represents 12 out of a total 42, or this rectangle has an area of 12, so it's also 12 out of 42. In other words, the commutative property makes sense. The order that you multiply the numerators never matters, right? As long as you're just multiplying. And in this case, switching the order actually helped, right? It helped us and be more efficient in thinking about the problem. All right, hope that helped.